Hello, 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 hello. Am I perfectly audible, visible? Am I perfectly audible, visible to everyone? So let us start. Let us start our class. Let us start. Let us start. Let us start our class. Let us start. Now I am going to start the class. Guys, please adjust. Something is fishy. Hi, Ishu. Hi, hi. So now we are going to beta lactam antibiotics. So what is meant by beta lactam antibiotics? We are going to discuss here. So the beta lactam antibiotics are the antibiotics which contains a beta lactam ring. Which ring? Beta lactam ring is the precursor molecule structure for the beta lactam ring. There is substitutions in the beta lactam ring. Okay, the best example for the beta lactam ring is penicillin. Is penicillin. If you see the beta lactam ring, which contains a three carbons, three carbons, and an amide group with a ketone group, double bond O. This is the cyclic amide group with a ketone group. So these beta lactam ring, the IUPAC name is agitadinon. You have to remember beta lactam antibiotics. Beta lactam antibiotics contains a beta lactam ring, which is the precursor molecule. The beta lactam ring, which contains three carbons with a keto group and with an amine group. You have to remember the structures in the medicinal chemistry. So don't by heart the structure or don't practice more. Just see what's happening. So here the amine group with three carbons, three cyclic carbon and a ketone group. So this is called as beta lactam ring. This is called as beta lactam ring. Now let us see why this beta lactam ring is more reactive and more sensitive to the nucleophile ring here, especially at the oxygen and nitrogen atoms. See, the oxygen atom which contains a two lone pair of electrons, and nitrogen which contains a single lone pair of electrons, and they're also having the electron negative groups. These are the electron withdrawing groups as well as electron withdrawing groups. These always things to withdraw the electrons, and they contains two lone pair of electrons, and here it contains a single lone pair of electrons. So this is the electron rich species. Same time it will also acts as electron withdrawing groups as well. So it is more reactive and more sensitive to the nucleophilic attack. So which kills the bacteria, but bacteria is more intelligent one. They having a resistance towards the beta lactam antibiotics. That resistance is beta lactamase. So what exactly is that? If you're introducing beta lactam to the infected body, the bacteria which is having resistance, which means the activity of beta lactam is, or the beta lactam antibiotic is destroyed due to the beta lactamase enzyme, so nowadays beta lactam antibiotic not that much potentiative, which means that much not that much power as the olden days, as their resistance power due to the plasmid DNA technology. It will be more interesting to study about the plasmid DNA and how the resistance power is generated towards these antibiotics, etc. Beta lactam antibiotics in earlier days there is sulfur drug, sulfonamides, but nowadays these are not used because of their action has been decreased due to the resistance power of bacteria. Okay, how the way we are going to kill this bacteria by using a combination therapy, which means we are, if we go to the market, we are having a tablet named as, we have a drug that is amox amoxicillin plus clavinic acid. Amoxicillin plus clavinic. If you correctly observed this amoxicillin plus carbonic acid, this amoxicillin is the beta lactam, and amoxicillin is beta lactam antibiotic. Obviously, it is going to the infected person to kill the bacteria. But but the major thing is the bacteria which is having the resistance power, na, that is, this amoxicillin power has reduced, which means working. This is not killing the bacteria. So the scientists had taken the combination with the clavinic acid. This clavinic acid is nothing but inhibitor, which means now what the story will be like this. This clavinic acid will inhibit this beta lactamase. Will inhibit this beta lactamase. When there is no beta lactamase, directly amoxicillin will kill the. So bacteria is giving the resistance, that resistance beta lactamase. Now we are giving a drug, that clavinic acid. This is going to block this beta lactamase. There is no beta lactamase. When there is no beta lactamase, obviously amoxicillin will not get destroyed, will not get triggered. Not only amoxicillin, we have beta lactamase antibiotics like penicillins, cephalosporins, etc. So this is the way now the beta. Let us observe how the cell wall is going to be synthesized. How the cell wall is going to be synthesized. Guys, am I perfectly audible and visible? Is everything is okay? I think it's okay. Okay. Let us discuss the beta lactamase mechanism of action. So if you see here, the general bacteria. So first of all, in the cell cytoplasm of the bacteria, the cytoplasm of the bacteria, first of all, there is an amino acid called N-acetyl glucosamine plus N-acetyl muramic acid, NAG and NAM. These having the peptide bond and the peptide chain and butyl chain. So these was generally synthesized in the membrane. After that, in the cytoplasm. After that, these are coming out, and here they are forming as a cell wall. This is a cell wall synthesis. So what's happening here? Here is there is a mechanism called transcriptase subunit, which means there was interlinking between this NAG and NAM. This NAG and the NAM. If you see here, this was the NAM and this was NAM. There was an interlink between these chains, these bonds, these peptide bonds. Now these